So here's a quick additional problem. So we are given that p of x is sine of 2x. The first thing we're asked to do is show that p prime of pi over 4 is equal to 0. Then we're finding p double prime of pi over 4. And then we're asked, what can we conclude about the point pi over 4 comma 1? So let's first address the p prime of pi over 4 equals 0. So first we take the derivative of p of x, noticing that it's a chain rule problem, so box around the 2x. So the derivative of sine of box is cosine of box, and then we multiply by the derivative of the box, which is 2. So ultimately, p prime of x is 2 cosine 2x. So now we're going to calculate p prime of pi over 4. So we're plugging pi over 4 into this, so we get 2 cosine of 2 pi over 4. Of course, that simplifies into 2 cosine of pi over 2, 2 pi over 4. And from trigonometry, we know that cosine of pi over 2 is going to be 0. So 2 times 0 is 0. So here we are. We've shown that p prime of pi over 4 is equal to 0. So now we want to find p double prime of pi over 4. Well, first we're going to find p double prime of x. So here we have p prime of x is cosine of 2x. Once again, chain rule because of the 2x. So we keep the 2. The derivative of cosine of box is negative sine of box, and then times another 2 from the chain rule. So when we simplify that, we get negative 4 sine of 2x. So again, we were asked to find p double prime of pi over 4, so we're going to plug pi over 4 into the p double prime formula, which is negative 4 sine of pi over 2. And again, from trigonometry, we know sine of pi over 2 is 1, so the answer is negative 4. So now we want to know what we can conclude about the point pi over 4 comma 1. Well, fortunately, they've given us the y-coordinate. We could plug in pi over 4 in here and get sine of pi over 2, which is 1, so that point is indeed on the graph, but we didn't have to because it already gave it to us. So now we need to think about what does it mean when we got p prime of pi over 4 was equal to 0, and what does it mean when we got p double prime of pi over 4 is equal to negative 4. So in our heads, we recognize that there's a stationary point at pi over 4 comma 1 because the first derivative was equal to 0 there. But now, because the second derivative is negative, we know the graph is concave down there. So we're going to put these two things together. So here's the point pi over 4 comma 1. We know it's a stationary point, which means the tangent line has a slope of 0, or the graph is horizontal there. We also know that because the second derivative was negative, the graph is concave down there. So it's going to look like this red graph. Wait a minute, that means that this point has to be a local maximum. Now you'll notice we were able to identify that point as a local maximum without using a sign chart. So this is an alternate way that almost always works, but there are some exceptions, where you can identify either local maximum or local minimum point by, instead of using a sign chart, using the second derivative after you've identified your stationary point to determine whether the graph is concave up or concave down. Now for your information, this is called the second derivative test. Although, again, it's not important that you remember the name, just that if you do happen to have the appropriate information, including the information about the second derivative, that you can recognize what that means on a graph. And that's the end of the example.